I take amyloid beta peptide, I dissolve it into a liquid. The liquid will continue to absorb the peptide until it cannot hold anymore, and then it will precipitate out. When something forms a precipitate and it's soluble, it forms an equilibrium. Things are going to be precipitating, redissolving, precipitating, redissolving, precipitating, redissolving. It's a dynamic thing. And my question is, and I've been looking everywhere for this answer, is there any reason that inside of the body these solid precipitates would behave any differently than in this simple model? That's my question. Now let me explain to you what I'm trying to do, or what my idea is, and then hopefully it will give you a better idea of the answer that I'm looking for. So a simple version of my idea. Take the example of salt. If I just throw salt into a cup of water, it will continue to be absorbed by the liquid until it cannot hold anymore, and then it will precipitate, and it forms an equilibrium. And it's dissolving and precipitating in an organized fashion. Salt is crystallized. It's going to be removed from the crystals, and it's going to precipitate onto the crystals. So much like the way these things form oligomers, organized structures, I don't think that that would be a problem, as my first point, as it happens in so many different things. But here's the idea. Since it's forming this equilibrium, if we're able to filter out salt somehow out of the water, then it interferes with the equilibrium. Stuff is redissolving, but it's not precipitating back out because it's being filtered out. So what will happen is, if we have a filter that filters out the salt in the liquid, then what should happen is that the precipitated salt will redissolve. And that's basically the idea. If we're able to somehow remove the dissolved amyloid that is in equilibrium with the solid, then the solid should redissolve. And here's how I plan on going about this. Or here's just a very simple idea. It doesn't have to be this. We can drill a small hole in the skull, create a semi-permeable membrane where the protein can pass in and out easily. And then on the other end, I'm going to make use of microorganisms, things like bacteria, that are known to have enzymes to break this stuff down. And of course, comparing this peptide to the size of a bacteria, it'd be a huge difference. It'd be like comparing a person to a building. So I know that it's already very possible to create a membrane that will allow these proteins, or not proteins, peptides, to pass in and to keep the bacteria out, and also to keep things from the brain in the brain, so we don't have an immune reaction as well. The immune cells will be kept out. If somehow an antibody was to slip through, even then, unless another immune cell sees it, it's useless. So it's like speeding, but a cop never sees you. It just never happened. So if these bacteria are able to remove this amyloid and break it down, then what will happen is a concentration gradient will be established, and it will funnel all of this amyloid into this container, whatever we decide to do. It will funnel all of this in there, and what will happen is, if this is being removed, filtered out of the liquid, then the solid will redissolve. That's the idea of it. And here's how I plan on proving the concept. I'm just going to get a petri dish. I'm going to go out and buy some of this peptide. I'm going to put it there. Next, what I'm going to do is I'm going to go to a mass grave, or some place where there has been a bacteria completely decomposing human remains, because they have decomposed the amyloid peptide. We don't look in the site of a mass grave and find a bunch of beta amyloid. It's not there because the bacteria have gotten rid of it. So we take a scoop of this soil, we put it in this petri dish, and whoever lives, that's who has the enzyme and who's able to live off of it. And then what I'm going to do is get one beaker, dissolve a bunch of this peptide in there until I can see stuff on the bottom, until I can clearly see it. And then in another beaker, I'm going to have this bacteria or microorganism. It doesn't have to be a bacteria. I just thought bacteria would be the easiest. And set up a semi-permeable membrane. And what is going to happen is this amyloid that is dissolved in the liquid already will diffuse into the other chamber. And once it's in there, hopefully the bacteria will do its job and eat it at a rate to sustain the bacteria's life and to read it. Basically, I'm just looking. I'm going to come back a couple days later and see if this solid has redissolved. That's the whole point. That's my idea. And it brings me back to, why do I even ask this? Well, I've been looking through medical journals just to look for some reason why someone hasn't done it already. I haven't seen anyone who's done it already. And to look for some other reason why it would obviously not work. I'm not looking for a yes or no answer that this should work. What I'm looking for is a reason someone would give me that I should not do this. Because if you look at the price of these amyloids, they're fairly expensive. For half a milligram, 1 milligram, you're looking at $100. And I want enough to where I can see it. So I'm looking to spend about $10,000 on this. That should probably be the maximum. Which, yeah, it's a lot of money. It's not enough money to where I wouldn't do it. But I thought I would ask first, because eventually I'm going to have to ask someone anyways. Because if this were to succeed or not succeed, it may be different inside of the human body. So that's why I figured I would ask first before I spent $10,000 pursuing this, because I'm going to have to do it anyways. So if someone could give me some input on reasons why it would obviously not work, unless there's like some unless there's some study or something like that that would prove that this wouldn't work, I'm going to do it. That's the whole point. I'm pretty much going to, I'm 90% sure, 99% sure really, that I'm going to do this, unless someone is able to demonstrate why this would be a bad idea. But that's what I'm looking for. I'm looking for someone to demonstrate why it's not a good idea to do. Maybe the amyloid sticks to the brain and it doesn't matter how much of it you filter out, it will remain a solid. That's what I'm really looking for. That's what I'm expecting. But if there are no objections, then I'm going to go ahead and proceed with this. So if anyone has any commentary on this, anyone can point me in a direction where perhaps I could find out a little bit more about it, then that'd be really, really helpful. Or if anyone has any other ideas to add on to it, that'd be nice as well. But this is the simple idea, and of course I have other ideas for mouse models and such, and honestly the cost is not going to be very much. So I just want to know, before I even get into all of that, I just want to know if this idea would work. Because if this works, then it should be it's a fairly simple test to see if it does work. And the next proceeding steps would be very easy. If it worked in a mouse model, then I can almost 100% assure you that it would work in a human model. So let me know if you have any input or any ideas. I'd very much appreciate them. Thanks.